Now, what we're going to look at that's a little new is taking what we know about graphing trig equations and writing equations from trig graphs, and we are going to use those in a real world situation. So, we are sitting on the deck of a river steamboat. Okay, the paddle wheel, the thing that makes the boat move down the river, a point on the paddle blade is moved in a way such that its distance from the water surface is a sinusoidal function of time. That means it's a sine or cosine graph. Okay, so when your stopwatch reads 7 seconds, the point is at its highest 20 feet above the water surface. Tells us that our wheel's diameter is 24 feet, and it completes a revolution every 16 seconds. We're going to do this in radians. Okay, so the paddle wheel has to be in the water for at least a little bit so that it can push the water along so it moves the boat down the river. Okay, now what we need to figure out is where a cycle could start. And this peak, wrong color, this peak, 7 seconds, highest height, 20 feet above the water surface, gives us a high point. That's a good place to start. A high, a middle, or a low is where we want to start a cycle. So in this case, being the high point, we're going to start that cycle high. So low, middle, low, middle, high, middle, low, middle, high. And here is our shape. It's starting high, so it's going to be a cosine, and it's not reflected. Now, we haven't put any numbers on this yet, but we already have the shape. Okay, so the next thing we need to do is start looking at the values it gives us. Okay, it gives us 7 seconds. That's a time. It gives us 20 feet above the water's surface. So that means this cycle starts at 7 seconds and the point is 20 feet above the ground. So that gives us the coordinates of our starting point. Now, the other information that we need to use here is the diameter. The wheel's diameter all the way across it is 24 feet. So if it's high, the point on the wheel, its highest point is 20 feet above, we need to go down 24 to find that bottom. So that bottom is -4. And if we think about a paddle boat, that negative makes sense because it's going to have to be underwater at least part of the time to push the water along to move the boat. So we got that value from the diameter. Now, the diameter is 24 feet. That means its radius is 12. So from 20 down 12 would be 8. Down another 12 would be -4. So this gives us our vertical shift 8 units up, and it gives us the amplitude 12. Now, horizontal shifting, we have our first cycle starting at 7, so that is 7 units to the right. The period of the graph is given to us, completes 1 revolution every 16 seconds. So 16 seconds after that point was at its first peak, its first high, it's at a high again. So 7 plus that 16 is 23, and plus another 16 would be 39. So those are the number of seconds where the point on the wheel is at its highest. Now, critical points are always period divided by 4. So the critical points are every 4 units. So 7 plus 4 is 11, then 15, then 19, then our 23. Keep going. We have a 27, then a 31, a 35, and we end at 39. Now, to write the equation, we actually need the B value. Okay, B value in radians is 2 pi over the period, which would be 2 pi over 16, which reduces to be pi over 8. So there is our B value. Now, we can write the equation. Y equals, vertical shift is 8 up. We are not reflected, so that's a plus. Our amplitude is 12. Our trig function is a cosine of our B value, pi over 8. New parentheses, x or theta. And then that horizontal shift is right 7. It needs to feel backwards. So that needs to be a minus 7. And there's our graph. Now, we want to be able to answer some questions about this in the calculator. So we need to put this equation in the calculator, and we want to fit a window that makes sense for this graph. Okay, so we look at the x-axis, look at the y-axis, consider the real-world situation, and let's figure some things out. So in the calculator, first, no, it's going to make me sign in again. I'm sorry, it's going to take about 12 clicks. So we want our calculator in radians. So go to mode, make sure you are in radian measure here. If you're not, click radians and hit enter. Second quit to go back, y equals. We had 8 plus 12 cosine, parentheses, pi over 8, open a new parentheses, x minus 7, and close those parentheses. Now, I can hit graph right now, but that doesn't really show me the path of this point on the paddle wheel of this boat. So what we want to do is look at our graph and fix our window. Okay? Now, at 7 seconds was our first high, but the paddle wheel was already going. So we do want to see on the calculator time equals 0. And then this cycle, second cycle, ended at 39. So I want to see at least 0 through 39 on the x. So I'm going to go to window, make that x minimum maybe about -3. Make that x max about 45. Keep that scale at 1. Now, for the y's, our y's went from -4 up to +20. I want my window a little bit further apart from those. I want my window to include -4 to 20 and a little bit on either side. So I'm going to go ahead and leave that y minimum at -10. I'm going to make that y max 30 and leave that scale at 1. Now when I graph this, we see a bunch of cycles of what the point looks like on the paddle wheel. It's a little more than our graph showed, but it works. So we want to take a look at question C. What is the first positive value of time at which the point is at the water's surface? The water height is the y value. So we're going to make y2 equals 0, and we're going to find the intersection. So go to y equals, make y2 equals 0, let it graph. It's that red line. Okay, now we want to find the first time. So second trace, intersect, enter, enter, scroll. The first time, see where my cursor is moving? The point is at the water surface is here. So we're going to hit enter. Notice, look at that y, it really is 0. That x is 1.142. 1.142 rounded to the thousandths. So x is 1.142 seconds. That is the first time at which the point is at the water surface. Now, that's not showing on our graph, the one we hand drew, but that's fine. Okay, now follow up D at that first positive value is the point going into the water or coming out of the water. If we look at the calculator, look at where that point is. The sine curve, sinusoidal curve, sine or cosine, is going up at that point. So this is coming out of the water. Okay. Now, E, how far above the surface of the water is the point when the stopwatch reads 2 seconds? Seconds is a time. Seconds is a time. That is our x. So x equals 2. I would go to the table. We already have the equation in y equals. I would go to the table, second graph, where x is 2. Go to that y value. Now, be sure you go to the y value in the table because it will have more digits at the bottom of the screen than what the table actually shows you. So that may make a big deal in some rounding. Okay, so this would be 3.408. 3.408. So this would be 3.408. And what units are we in? Feet. This will be feet above the water. So that's how we make a real life situation into a trig graph and trig equation. That's all, guys. Bye, y'all.